All right, this is my video on how to use arrow diagrams to do the chain rule. So taking derivatives of functions that are composed with other functions. The process starts out with, first of all, building the arrow diagram for a particular function. So we're looking to take the derivative of the square root of x squared plus 5. So we'll start with an x, and that x gets squared and creates an x squared. These are important to write in the middle here. It's not necessarily important on everything that we do with arrow diagrams, but it is here. And then we're going to subtract 5. That'll give us the x squared minus 5. And then finally, we're going to put that in the square root, which in calculus we prefer to call the 1/2 power. Okay. Now, what I'm going to do, the beauty of this is I'm going to focus just on one little piece of this, and if I look at this particular piece, its derivative of x squared is 2x. We write that as 2 with an empty set of parentheses here. The derivative of this piece, well, that's just an x minus 5. Derivative of x minus 5 is 1, because it's a straight line, slope of 1. And the derivative of x to the 1/2 power would be 1/2 x to the negative 1/2 power. Okay. And so this is all that I need. I'm going to put a little bit more space in my parentheses here. Okay. But this, the empty sets of parentheses, as always with an arrow, they take whatever is at the beginning of that arrow. So the beginning of this arrow is an x. There's no empty set of parentheses in this second part, so nothing to do there. But this empty set of parentheses over here gets what is at the beginning of that arrow, which is an x squared minus 5. And then we multiply these pieces together. Okay, so if I look at that, I've got the 2 times the 1/2, those are going to cancel. I've got a 1 times an x. This looks like what I have left is an x in the numerator and a square root of x squared minus 5 in the denominator. And that is my answer. That is the derivative of the square root of x squared minus 5. Okay. Let's look at another example here with a little bit more going on. We'll start with the x as we always do, and then we multiply by 5 to get a 5x, and then we do the secant of that. That will give us a secant of 5x. And then we're going to do the sine of that. That will give us the sine of the secant of 5x. It's important on the sine squared to recognize that sine squared is not the simplest function that we can break things down into. We need to take the sine first, and then we will square. And that will give us the sine squared of the secant of 5x. Okay. It's an important thing here. Don't ever put anything on an arrow that you don't know the derivative of. And you probably don't know the derivative of sine squared. So we're not going to put sine squared on an arrow. And then finally, we multiply here by 2. Okay. So if I put my focus on just this is like a 5x, and the derivative of a 5x is just a 5. Straight line again with a slope of 5. Derivative of secant, we know that one. That is secant blank tangent blank. Okay, or secant x tangent x, and we leave the blanks there. Derivative of our sine, I'm getting a little crowded here, but we'll fit that in here. Derivative of sine is cosine. Derivative of x squared is 2 times x. And the derivative of 2x is just 2. And we come through and we multiply. Well, we're not quite ready to multiply everything together yet because we have some empty parentheses. This was at the bottom of this arrow. At the beginning of that arrow was a 5x. So we get 5x's in these sets of parentheses. This one had a secant of 5x at the beginning of its arrow, so it gets a secant 5x in there. This, I'm going to have to create quite a bit more space for myself here. This one is going to get the whole sine of the secant of 5x in it. And then times the 2 at the end. In fact, all of this stuff is now getting multiplied together here. Okay. So the constants that I have here, I've got a 5 times the 2 times the 2, 4 times 5, sound like a 20. And then I'm just going to start listing the other stuff that I have. I have a secant 5x, tangent 5x. I've got a cosine of the secant of 5x, and a sine of the secant of 5x. And that is the derivative of 2 sine squared of the secant of 5x.